Polynomials. In this short video, we're going to go over some important vocabulary terms that relate to polynomials, because polynomials are one of the largest and most important families of functions that we study in Algebra 2. So, the standard form of a polynomial is probably what you're used to seeing. This is the form of a polynomial written with the terms in order by descending exponents. For example, you might see this function f of x equals 3x to the fourth minus 2x cubed plus 5x minus 7. The degree of the polynomial is this first exponent that we have, and notice that the exponents go in descending form. Now if you notice, there's not an x squared factor, and that's okay. You don't have to have every exponent possible represented, you just have to have them in descending form, because this makes it a lot easier to tell what the graph of that function is going to look like. Now, this first term, when it's in standard form, tells you the degree of your polynomial and the leading coefficient, which we tend to abbreviate LC in this class. So the degree and the leading coefficient are going to determine the shape of the polynomial. Another way that we commonly see polynomials written is in factored form, and this is the form of a polynomial that's written with linear terms and irreducible terms. Irreducible means you can't break it down anymore. For example, f of x equals 3 times x minus 4 times x plus 2 times x minus 8. In this one, we see three linear terms, and if we multiply them all the way out, we would have our polynomial in standard form. And this is just the factored form of the polynomial. Now, in this case, the degree is 3 because we have three linear x terms. And our leading coefficient is 3, and that's the number parked out front. Now, the official definition for the degree is the highest power in a polynomial. A polynomial doesn't have to be written in standard form or factored form. You can still determine the degree because you can find that highest exponent. And that highest exponent, it was what determines the behavior of the polynomial. Now, the leading coefficient is the coefficient of the term that has the highest degree. It's not the biggest number, it's that number you see out front of the variable that has the highest degree. And the leading coefficient, be it positive or negative, is going to determine end behavior of the polynomial. So what the polynomial ultimately does as it shoots off to positive or negative infinity. One last term. The solutions, also known as the zeros of a polynomial. These are the points where the polynomial crosses the x-axis. And these are very interesting points.